Hey patrons, hey everyone. Whew. Today has been one heck of a day already. I don't know if anyone else has been paying attention, maybe the sun, just a little bit. I have been running around like a chicken with my head cut off. And make sure everybody, can you guys hear me? Good, Michael Richardson and Jerry, you're both in here. I have my cell phone with me. So if something goes wrong, go ahead and ping me. Oh my goodness, I'm flustered. Yes, we do have an X flare that has happened a little bit earlier today, and my mind is just in about 17 different directions just because I'm trying to get lots of data products done, trying to answer questions on the fly for everyone. So I decided to have a live informal forecast. And what I will do my best to kind of go over everything quickly. So for those of you who just want the information and to get out, um, I'll do that. So everybody knows I'm working on getting these space weather briefings more polished. So that's what I will try to do at first, and then we will go back and do a deeper dive for those who want to stick around and see lots of stuff that's coming. Okay. So hello everyone. It sounds like everybody's here. Excellent. Notani says audio is loud and clear. I see a lot of people here today. This is fantastic. We've got almost 171 people have joined us. So I think this is fantastic. I will get to your questions and comments, and I will read everything. So if I don't get to you, Patreon members, definitely put your questions in the Patreon feed as well, especially if I don't get to them here in the YouTube chat, okay? Because you guys have priority. All right, so let me start off. Remember, this is an informal forecast, so it's not quite as polished as my formal one. So I don't have numbers for you. But here's region 2891. We thought this was going to be the player that was going to light up an X flare. But then this one, region 2887, that had been kind of quiet for a little while. Look at that monster go. Boy, that was a big one. That was the X-class flare. It had actually been firing off little M-class flares prior to that, and so was region 2891. But this one fired off several M-class flares. There was actually one that actually did launch a solar storm, and then it really went. Here, just a moment, you'll see it going boom. Right about, come on, ooh, right there. And you can see there's this blast wave that actually propagates up the disk here. I will switch in just a moment to a picture that kind of like shows it, kind of unfolds the whole process for you so you can see it in better and get a better understanding. But the reason why this has actually been a very exciting X-class flare is because it launched. It has not only was it in the Earth strike zone, right, which is it for CMEs, for coronal mass ejections, which is what it erupted. That is called the Earth strike zone. It's right in the middle of the sun. It's different when it's fast solar wind, but when it's an eruption, you really want that active region to be pretty much in the middle. And the other reason why this one is reasonably exciting is because it actually launched a very dense filament structure, and that we saw in the core of that active region. And I'll show it to you in just a second. So I'm expecting that this one is going to pack a punch no matter what. If now, when we talk about these big eruptions, there's two things that have to happen, right? Well, first, obviously they have to be Earth directed, and this one is, but they also, to pack a punch, they have to be fast, right? Fast and dense, and they have to be able to have the right magnetic field configuration. Obviously, the magnetic field configuration is not something we can predict, but we can tell, before it hits, but we can tell if we have a fast structure. And not only is this fast, but it's also dense. So even if the magnetic field orientation of this particular solar storm is wrong, is not conducive for a big reaction at Earth, just the bumper car effect from this thing slamming into Earth so hard is going to make the Earth's field wiggle and wobble. And so initially, we will end up seeing a big impact no matter what. It's going to be a bigger deal for people at low latitudes than high latitudes because that's where we get, if anything, we might get a small EMP from this. It's a G3 or an E3 kind of EMP, so don't worry about it. It's a slow EMP. Don't worry, your pacemaker, your car phones, your car batteries, your cell phones are not going to go all wonky. Don't believe the hype when people say power grids are going to shut down and all your little electronic devices are going to shut down because we have this massive EMP. No, it doesn't work like that with big storms like this. They're a lot slower. And so you have to have, if your car battery were the size of Lake Michigan, then I'd worry. So really what it comes down to is that it's going to put a little extra strain potentially on the power grids, but they'll be at low latitudes, at least if this thing is just a bumper car. Now, if we worry about it being a big solar storm that has the right magnetic configuration, well, that's a totally different story, and we'll talk about more about that when I get into the deep dive. But at any rate, this region erupted just a few hours ago on the 28th. Obviously, today's the 28th. I think it was at 15:30. Let me just freeze it here for a sec. Let me get to that point. Boom, right there. So about 1500 hours, and this is UTC. Okay, so as you'll see in the predictions, this structure is moving quite quickly. And I'll flip over to some chronograph images that we've gotten this far, but the early model runs are being done mainly by stereo chronographs, which sadly, well, in all of these cases, these chronograph images are showing this big structure coming toward us, and it's really hard when you have something coming straight at you. It's really hard to get a good speed estimate. So scientists are doing the best they can, but this is actually the worst kind of prediction or worst kind of observing geometry we could have for a fast solar storm. We really like to watch them coming out from the side. So like if I were stereo and I were blowing it out this way, or if the sun was a sun blowing it out this way, and you were stereo watching this structure move out, you get a much better view of the structure as it moves out sideways than when it comes right at you. So we'll see that in chronographs, but just know that that there's going to be a bit of a kind of an uncertainty to the solar storm forecast, all the prediction models, because of that. Okay, I will also show this to you in 304 angstroms, if for no other reason than you. Well, I'll show it for several reasons, but it's a really beautiful eruption, and you can see. Whoops, is it going to show me? Did I load the wrong data? No, it's right there. Okay, sorry. It skipped it, did it? No, you'll see it here in just a second. Right, there's the first, that's an M-class flare there, I think. And then we had the big one right about, oh, those are the M-class flares. Right there, boom. Now, what I want to show you here that's really reason why I'm, I don't want to say concerned about this one, but why I think that this structure actually has some potential for packing a wallop is when I zoom in, and you'll see it as we get closer. As I zoom in right here, look at all this stuff. I'm going to rock it back and forth. This is where some of those M-class flares were occurring, right here. Okay? But hopefully you can see this. Do you see this really dense snake in here? That little tiny worm? That's a core filament structure. Anytime we have those core filament structures in an unstable active region that has X-flare potential, boy, that's a mouthful. That means if that thing lifts off, there's a very good chance that we're going to have a solar storm that's very strong, okay? Because there's some really strong magnetic fields in here. And sure enough, you can see it firing. Look at it lighting up. Can you see the electricity kind of stuff? The light, well, it's not really electricity, but can you see the fire, right, for lack of a better phrase, all around that little filamentary structure, all around that little worm, okay? Look at it activating right there, for example. See how it's all activating all around that little worm. Okay, that's how we knew this structure was likely going to go. And very shortly thereafter, there's another one. See that? Look at that. That whole worm lights on fire. Okay, a lot of very strong magnetic fields breaking. And sure enough, when this thing goes, boom, that's what this structure is here. If I can get my hand in the right place. Okay, this is the plasma that was inside that, and it's very dense. And likely the magnetic fields in this structure are very strong. Now, one of the things we have going for us in terms of those who are frightened about this level of solar storm, don't be too frightened. The bulk of this structure is going to go south, at least the densest part of it, okay? What you will see very shortly when I play this or when I show you the pictures, is that you'll see that a lot of this structure, at least the part that's more Earth directed, that went northward of this blast out this way, that is more of the overlying fields, and I don't think they're going to be nearly as strong from the perspective of a solar storm. But it'll be interesting to see if we hit if we get the core of this. Scientists are going to be super excited about it, guaranteed. So let me switch to that really fast, so you can see this picture that I'm talking about, and I'll zoom in. So this is something I posted both on Patreon and on Twitter. As you can see, it's a very long running kind of thing. That's kind of one of the guns that I always do when these events happen, so I can kind of break it down for you. I'll also post it on Facebook if you'd like, a little bit later on, and if you guys need me to post it here on YouTube as a post, I will do that as well. But you will see this structure, this picture again when I do my formal forecast. So as I was saying, the dense filament structure, there it is. See that little thing right there? Okay. Then we had our X flare, and I'm gonna see if I can pull up so you can see the times. So anybody who needs to see the times, okay. So we had our X flare. Where's my mouse? Okay. And then you can see that dense filament erupting and evolving, right? So you can see it in multiple wavelengths. That is where the core of the structure is. This is really dense. It's cold. Okay, that's why it almost looks like a coronal hole. This is not a coronal hole, guys. This is very cold, dense plasma. It's not emitting light in this wavelength, and that's why it looks dark. Okay, but it is a dense filament. Okay, here it is again, right? A little bit further along in the eruption. Okay, but most of that stuff, as you can see, is going pretty much southwest. That dense core stuff is going southwest. I don't know if it's going to end up being something that hits Earth. However, this is what I wanted to show you. Above that, do you see this big evacuation? You see all of these, the darkness in here, okay? Those are dimming regions that did not exist before. So when this thing blew, it launched a lot of stuff that way, granted, but it also launched a lot of stuff out this way. Luckily for us, the stuff that's out here, not going to be as magnetically strong. So it's going to be interesting to see if we see the core of this structure where that really dense filament came from or not when it all arrives at Earth. Hard to tell, okay? Especially early on when we don't have that much in the way of coronagraph images. Thus far, the coronagraph images from stereo are pretty ratty, and I'll tell you why here in just a second. This is the only bad thing. When you have really big solar storms like this, they're very fast, and so you don't get you don't just get the solar storm, you get a radiation storm too. Radiation storms have a tendency to blind coronagraphs. It's like, when it rains, it pours. Okay, let me see if I can. So let's take a look at this, and you and I are going to look at this together for the first time. Uh-oh, maybe we're not. Okay, I think I'm gonna kill this one. I think I've got an issue with memory. I've got too much stuff up. Let's see, because I do have a lot of stuff up. Let me kill that. We'll get to 5 days in a second. See, sorry, this is informal, guys. If I can, it's not gonna play. Oh, you pain in the butt. Let's reload it. Okay. Take a sec just to reload. Sorry about that. Wonder if my chronograph is going to play. I might as well play the chronograph. Yeah, good. I'll play the chronographs first. Okay. So let's quickly skip to chronographs. All right. So this is the stereo chronograph. And if you recall, the stereo spacecraft, Stereo A, is not that far away from Earth right now. So it's actually just east of Earth. So if we were looking at a halo chronomass ejection, right, a halo CME, that's going to, and remember what a halo is. A halo is a signature that goes basically all the way around the sun. If it were coming straight at stereo and perfectly aligned, it would actually be a halo all the way around. In this case, as I stop, oh, it won't stop, you stupid thing. Let me let it play one more time and I'll stop it here in a sec. Come on. Now remember, this is beacon data. Let me go back up a little bit. So it's not that stereo is old. Okay, that's not the problem here. The problem are two things. One, this is data that we get in real time. It's degraded on purpose because we're trying to get it in fast. So we actually suffer quality. It's a low resolution image. We suffer quality for speed. Okay, it's important that we get these. That's why they're called beacon. It's important we get this beacon data down here earlier than real time. So that's why one of the reasons why the image quality is degraded. The other reason why the image quality is degraded is because we have a radiation storm going on right now. Radiation storms blind coronagraphs. So this data looks really ratty. And granted, this is a difference image, but the data looks really ratty because we are dealing with a radiation storm. all right, and low resolution. So from stereo's perspective, you can see this is a partial halo, okay, and it's very bright, okay, even especially in difference images. But I use difference images for beacon data because it usually looks better. You know what? I probably should go back and check to see if that's the case with a radiation storm. Maybe it's not. All right. Anyway, sorry. I lost my train of thought. Where you can see this structure is actually a bit, tilted off to the west, right? The southwest. So south we knew. West makes sense from stereo's perspective because stereo is offset from Earth. So the fact that we're seeing this move basically as a partial halo off to the west does mean that we're probably going to see almost a perfect halo in LASCO. And I think we're just beginning to get the LASCO imagery now. So I'll show you some of that here in a sec. But you can see this structure is quite dense, okay? And it's one of the densest that we've had, maybe the densest structure that we've seen for solar cycle 25. So again, another indicator that this is going to be a strong solar storm. Oh, good, this is working now. Okay, so if we go back to stereo on the far side, so we can just take a look at what's happening on stereo. Why is it going to the 24th? Goodness gracious. Hold on. All right, let's just start here. Frame start 598. Okay. No, I don't want this downloaded. No. Okay. All right, so here is stereo, and yes, you can easily see it. So like I said, we're looking at this for the very first time, or I'm looking at it with you the very first time. So I get to kind of point out all the fun bits. So you can see region 2891 was really going nuts, right? And then suddenly, I guess 2887 got jealous because it started getting busy. And as it started getting busy, it decided, I think it's this one here, it decided to fire off that flare, okay? And I'll show it, I'll keep letting it, circle back. So as you can see, we've had a couple things. They're not radiation storms yet, but we have been getting some low-level radio bursts. But if we get that region popping off, boom. Do you notice as soon as you get that big region popping off that everything in stereos, even in this EUVI image, gets kind of ratty? Once again, that's the radiation storm. It's impacting the sensor. Okay, so again, watch this. As soon as you see this region blow, boom, right there. See this ratty stuff? That is protons. This is a proton storm, okay? This is a radiation storm that's just beginning to hit Earth. The reason why you see it more with this particular instrument in this particular time than you've seen it in the past is because this particular radiation storm is actually quite hard, meaning it's got high energy particles in it. A lot of the lower energy particles we can actually manage just fine and it doesn't impact the sensors. But some of the high energy stuff really impacts it. It actually impacts to the point where it's actually going through the electronics into the electronics box. So this is really hard dose radiation right now. As a matter of fact, I've gotten a report from people who work at the SHRAG that they're on contingency mode right now because they don't want the astronauts, I guarantee, are in the bulkhead or keeping themselves safe because we've got high radiation doses right now. And I will talk about that here. Hold on. Let's go home. Okay. So as you can see, here is, and I will pop up the X-ray flux here in a sec, but since we're on the radiation storm, I'll talk about it right now. Okay. So here is the radiation storm. Let me just zoom in a little bit for you. Oh, boy, I'm kind of in the way, aren't I? So as you can see, here's the Space Weather Prediction Center 10 MeV warning. This is for the low-level particles, okay? So what you're looking at here is you're looking at a time plot of basically our radiation storm monitor, okay? And flux goes up this way, meaning the number of counts, the number of particles. And you see 3 traces, okay? The 3 traces represent different energies, okay? So see, the Space Weather Prediction Center has basically two different kinds of warnings. One, and you can get to an S1 radiation storm warning, which is where we are, okay? And that's when that red line, which is the lowest energy stuff, it's 10 MeV or greater, if you're interested, that goes above this dashed line, okay? So that's where we are. We're at that radiation storm warning now. How we know that this is the hard spectrum is because you see the blue and the green line, especially the green line. The green line is for particles that are protons that are 10 times worse, 10 times more energetic, meaning they slam through things a lot more. So they can slam through hulls of spacecraft, through hulls of airlines. Okay, we've got a serious radiation storm right now. Now, anytime that green line gets above essentially 1, which is this 10 to the 0. Sorry, I'm off on the side here. So this dashed line right here to my disembodied hand, right there. Anytime the green line gets above that, okay, that's a marker for, we've got a serious radiation storm. So if any of you are high-risk passengers in flights and you're planning on taking an discretionary flight, something that you may not have to take, probably a good time to just maybe wait a day or so, maybe 2. Okay, maybe till after the storm passes, right? Because we have a solar storm on the way, and all of this is going to stay elevated. I mean, the 100 MeV stuff, the green line will probably go down just a little bit as the storm gets closer, but that red stuff is going to stay. It's going to stay elevated up probably past the S1 storm level until that solar storm hits, which will be on Halloween, we believe. Okay, so again, I'll go into a deeper dive here in a minute. What I will do is, do I have it up here? Yeah. Where are you? Where's my thing? Oh, here it is. Okay. So this, for those of you who know or who are ham radio operators, you might recognize this. This is the DRAP model. I have a movie of this that I'll show later, but you can see the DRAP right here. This was during that X-class flare. It was actually almost during the entire Western Hemisphere was lit up like a Christmas tree. So if you happen to be in the United States or Canada earlier today and all the bands went dead, now you know why. It was the X-class flare. Things have changed a little bit here, and here's the X-class flare for the X-ray flux, as you can see. I'll go to a live picture in a second, but I wanted to give you that view. If I go to a live picture right now, how do I get out of this? Escape? I don't know why Swipsy's been doing this lately. I'm having the hardest time getting out of these things. Okay, so here's the solar flux. I mean, not the solar flux, the X-ray flux. And something I want you to see, again, here's how that big X-class flare evolved and is what we call a long duration flare. But what I want you to pay attention to is the fact that the background levels are still quite high, okay? This means that since this was kind of the background prior to that X flare going, and you notice the background levels are still basically at the same level as before the X flare, maybe a little bit higher, right? So you've got the background levels here, and I'm looking at the red-orange line, not the blue one. So the background level here is actually lower than where we are now. Okay, so this region still has stuff to do. It's not decaying that fast. So something is still going on, and there's a chance that we're going to have more big flares coming from this region. Okay, just because we had one doesn't mean anything. It means we've had one flare. But with that big filament being, that core filament being gone, there is a chance that this thing will flare and not give us any more big solar storms or solar storms at all. It could simply flare and flare and flare and not give us any more storms because it did take care of a big core filament there. But we shall see. Nothing is ever etched in stone. I'm trying to think what else is super important to give you right now. Oh yeah, of course. Of course, I know what's super important. If I can find it. Bum, bum, bum. Annotated. There we go. So, and believe it or not, NASA was nice enough. Hopefully this will loop. We'll see. Are you going to loop? No. Can I make you loop? Yes. NASA was nice enough, even though we don't have very good coronagraph data as of yet, NASA was nice enough to give us a model, a preliminary model. Now remember, this is early from only stereo chronograph data. So it's kind of hard to tell. We need, especially when these things are halo coronal mass ejections, these halo solar storms coming at us, makes it difficult for us to get the speed just right. But you can see, for those who are not familiar, this is NASA's version of the NLO model, and we're looking at density. We're looking down at the sun from the North Pole, and Earth is this little yellow button off to the right. See that little circle? That's Earth. All the other stuff are other spacecraft that we have or other planets. And you can see the legend above me here. So this is the ecliptic plane. Those pinwheels are fast wind streams, or really the density enhancements in front of them. But you can definitely tell where that solar storm is, right? That's that big blob of stuff, that big banana that comes out, right? And if we look at this panel here, this is actually what we call a meridional cut. It goes from north to south right at Earth. So it's slicing. It's like I took a slice right through the middle of this, okay, from the sun out to Earth. And you can see in this cut that, yes, the bulk of the structure is going south of Earth. You can see it's kind of offset a little bit. So we're going to be sitting in the northern part of it. Whoops, my hand in the right place. We're going to be sitting in the northern part of it, okay, up in here. See how much less that is up here? The center of this structure looks like it's going right about through right there or so. So beneath Earth. So the chances of us not getting hit by that core filament structure is, maybe. I don't know. And so we'll see more refined models as time goes on. Let me pause this so you can actually see when the impact time might be. Oh, perfect. So the impact time definitely looks like it is going to be the 31st, right at the beginning of the 31st. Okay. So really by Halloween, we should be seeing something. And it does look like, if we look at the impact footprint, remember this is flipped on its side. So north and south are sideways. But you're going to see that impact footprint, when that CME smashes all through Earth or around Earth, we're going to be pretty well enveloped. So we definitely do believe that it's going to be a decent solar storm. It does look like it's moving pretty fast. So expect, if nothing else, expect to get a decent wallop early on. And then if the magnetic field configuration does not agree with us, then things will kind of quiet down. And actually, amateur radio operators, I know you're going to be not on the good side of Aurora people, but if the magnetic field actually is the wrong way, is the way that doesn't cause a geomagnetic storm, it'll actually help you with your contesting this week. So I'm sure amateur radio operators are going to be praying for northward field. Aurora photographer is going to be praying for southward field, because southward field will give us some great aurora, possibly easily down to mid-latitudes, possibly deep into mid-latitudes, because we're looking at a potential G3 level solar storm. Okay, and I agree with Swipsy's prediction here, and that's what I'll do now, is I'll go to the 5-day outlooks, and then we'll start doing a deep dive for you all, for those of you who want to stay. How do I present? Okay, there we go. Okay, for those of you who actually look at the Space Weather Prediction Center's predictions and their 3-day outlooks, yikes, they've got something a little squirrely. They are expecting a G2 and a G3 level solar storm, and that is and that should be G2, my fault. This should read G2, hold on. I made a copy paste error. I do not want that on here for anybody to take home with them. It's one of the nice things about using Google Slides. I can fix it quite easily. But for those of you who pay attention to the Space Weather Prediction Center, they have really weird predictions for the probability. They actually have the probability of a major storm down to 1%, and yet they expect on the 30th to have a G2 level. So that's a KP of 6, which obviously is it's inconsistent. So I went ahead and switched stuff around and did it this way. We do expect to have, at least by the 31st, that the biggest part of that hit. It could come earlier, and this is one of the reasons I think why at least NOAA is saying we could have a G2 level earlier on. They're definitely knowing that they're going to get that big bumper car impact, because this is a fast moving storm and it does look to be dense. So that's why you're seeing that. I don't know if this is going to last as a G2 into 31st, into the November 1st, and then as long as a long duration kind of thing, because we just can't early on predict what level of magnetic, whether or not the magnetic field configuration is going to be big. But expect it to possibly be hitting pretty hard on the 30th, and stay in the space weather community. Took a look at our real-time community on Twitter to be able to get updates, or join us on Patreon and keep with updates there. I'll be updating people all the time. If it ends up being a G3 level, that means a KP of 7. It'll happen at high latitudes, likely not at mid latitudes. Likely at mid latitudes, we'll see a G2, but this is still good enough to get you aurora clear down to Colorado, down to New York, down to easily Iowa, easily Oregon, possibly Northern California. Okay, we get some good chance to get aurora there, but you're going to just need to pay attention. And if you're at high latitudes, obviously you will likely have to look south for the aurora. If you're in the northern hemisphere, because the aurora will go straight over you, and you'll actually be looking at the southern sky in order to see aurora, not the northern sky. And reverse, in the southern hemisphere, if you're looking at aurora australis and you're at high latitudes, in the Antarctic, for example, you may have to look north for your aurora. But I do believe that there's a chance with aurora australis, definitely New Zealand and Tasmania, if the sun is going to cooperate with you, because I know it's going to be getting brighter there, and possibly into Melbourne and the lower tip of Australia, Victoria, that whole area. And we're not that far away from the equinox, so we definitely could be seeing some interesting stuff from this storm, because it's a good magnetic connection to Earth right now. Who is talking? Let's see. I'm hearing bing, bing. So I have to see who's talking. Okay. Oh, good. Okay, I'm gonna see some stuff on Patreon here. I'll look in just a moment. So let me get through this last bit, which is my 5-day for solar flare and particle radiation storm outlook. Obviously, not everything's in the green this time. We have a lot of active regions on the Earth-facing disk. 2886, 2887 is the big X-flare player, but we also have a little bit of X-flare risk from region 2891 as well. So we're at an X-flare potential of 25%. That's our flare risk right now. 60% chance of more M-class flares. So yes, radio blackouts are absolutely possible on Earth's day side. And this is going to continue easily through this week. So sorry, I mentioned to you guys that the risk was going to ramp up, but it ramped up a little more quickly than I had hoped. But we didn't make it through the weekend for the contesting, because I know there's a big CQ contest this weekend. But yes, expect radio blackouts. Don't worry. Don't check your rig. Don't climb your antennas. Most likely it's the sun. Blame the sun and check the sun first before you start tearing your rig apart and thinking that there's something wrong with your radio. And then the nice thing, though, is that we do have some high solar flux. Look at that. We're back in the green. We're back into triple digits. This will easily last over this week as well. So this is good news for amateur radio operators. Not so great news for GPS users, because especially you GPS users at low latitudes, you're not going to like the fact that the solar flux is climbing. That means GPS reception at low latitudes, even on Earth's day side, gets a little bit ratty. So just be aware. And right now, high latitudes are a problem. If you guys are dealing with, if you're a high latitude HF communicator or even VHF, you could be seeing some issues, and that will easily last through the 31st. We will probably be at an S1 level until that solar storm hits. And then we will likely drop reasonably quickly below an S1 level, and then slowly go back to nominal over the next, maybe 4 or 5 days, maybe 3 days. And I'm saying hard spectrum, so this is basically telling people who are high risk passengers, you are getting a decent dose right now of radiation, and you will over the next 3 days. If you can avoid flying if you're high risk, or if you're pregnant, if you're a female who's pregnant, definitely take that into consideration, because just a few days from now, it'll be much, much better. Okay. And if you're a pilot, be aware there are space weather advisories. I'll pull up the space weather advisories in a minute, but they have space weather advisories right now, ICAO advisories for HF comms, and I guarantee you they'll have one very soon for radiation storms as well. So hopefully that is a nice, short enough, I know it wasn't super short, but it's a short enough brief to allow people who just wanted the facts and gone to get what they needed. And now the rest of us, I will open it up for a deeper dive for questions and things like that, including, hold on, I will pull up just for kicks the radiation advisories, the ICAO advisories. It's so nice to finally see ICAO giving radiation advisories now. Not radiation, but space weather advisories. So any of you who are pilots, definitely take a look. There have been several advisories being given As you can see, we're talking about space weather event, the flare in progress. This is impact on lower HF comm frequency bands expected on the daylight side. They say high frequency bands may be less impacted, but we will see. I have not had a chance to check to see what type of radio bursts we're getting from this region, and if we had a high frequency radio burst. So I don't know if this is an accurate assessment. Definitely low frequency bands. The HF bands are being hit. But I don't know about the higher ones. And again, we may not be completely out, and this is not addressing radiation dose and radiation storms. So those of you pilots, definitely, if you have a capability of assessing your radiation dose during flights over the next few days, please do so, because it will not be nominal. Okay, you've got an additional risk. Okay, so let me answer some Patreon questions first, because I promised everybody that I would do that. So if you happen to be a Patreon member, you guys are the whole reason why I'm able to do this at all. So I'm going to look to see what kind of questions we have. Thanks, Lex. Thank you for this great opportunity to get questions out and mitigate anxiety. I'm afraid this will be an 8 or a 9. No. Okay, can I help with that? This, I guarantee, this is not going to be, I would be very shocked if this were a KP9, 8 or 9 event. So you're talking about one of the superstorms. First of all, it's only an X1 flare, okay? Granted, there's a density, that density plug in there is a problem. But I think the bulk of it will be going south of us, which is nice because even though it is a direct hit, it's still not perfectly aligned. Oh, which reminds me, let me pull up. I think we're beginning to get some decent data now from maybe I'll reload, SOHO, LASCO. I think we're just beginning to get it. I'm standing in the way, I know, I'm sorry. So yes, okay, so we're beginning to see a little bit, not much yet. And this is not a difference image. Okay, but yeah, if you notice, so you can see the halo, right? And yes, it is more symmetric. Just like we mentioned, it's stereo, it was pointed more to the west. Here, it's much more symmetric, but it is southward, okay? We got the bulk of it still going south of us. So that's good news in the sense that we may not be getting right through the middle of this structure. It may not be as big an impact from that perspective in terms of the density or the duration. Now remember, with power grids, what matters is the duration of the storm. Just about any power grid can handle a KP of 9 if it doesn't last more than 3 hours or 6 hours. If it's going to last, 6, 12, 18, 24, then it starts becoming a real strain. So that's really what we're going to be looking for, is that how long is this solar storm going to last with the magnetic field configuration in a bad way, okay? The longer the storm lasts, the more that auroral oval opens up, the more ratty things get, and the more strain that the transformers have to take with this extra current being induced into their lines. And that comes from the conductivity in the ground. And remember, it's also a matter of it is a matter of where you live, right? So high latitudes are going to be affected more than low latitudes. And if you happen to be in the United States, you are going to be affected if you're on the eastern seaboard and a little bit like in North Dakota, those areas, they get more, they have more issues than other areas because of the conductivity of the ground there. And I'm trying to find, is it the electric field? That's the comparison. I always forget which one it is. I think this is it. Yeah. Okay. So if you get worried, there is this Space Weather Prediction Center has a product called the Geoelectric Field 1 Minute, and I will be monitoring this when the storm hits. Okay. And right now you don't see much because there's not much going on. It's a pretty quiet field. But what this is telling you what the electric field is basically in the ground that could then be induced into power lines. And you can see here, you're really not, you're seeing, I don't know if you see the numbers, but they're like 50 and 60, 40, 30 millivolts per kilometer. This would have to be in the thousands, if not tens of thousands of millivolts, because you need volts. You need like 20 volts per kilometer to really start seeing issues with grids, and it needs to be sustained. Okay, so we'll be monitoring this, and we'll let you know if things look like they're going to be an issue. But I don't think that this storm is going to be strong enough for that. I do believe that we have a good chance, but definitely a good chance for G2, possibly even G3. Okay, but again, it's how long that solar storm is sustained at those levels that begins to make you worry. And remember, the NICT and the FERC, which work in both Canada and in the United States, the national grid in the UK has their own things that they implement, but there are mitigating procedures that they implement to be able to allow their grids to ride out these types of storms, and they're very, very well aware of it. And the Space Weather Prediction Center is making phone calls all the time. Okay, so they are making phone calls right now to let them know it's coming. And these guys, basically what they have to do is they actually have to turn off a lot of their alarm systems and their safeguards. The safeguards shut grids down when the grid gets overloaded, which you'd think that's smart to do. Well, it is in a normal situation, but not in a solar storm situation. It's actually better if they ride it out, because there's something called reactive power that they need to keep up. And it prevents having grid collapses. So that's really what's important, is that they don't take the grids offline. But I will come back on and let you know if things get a little bit crazy, and then we can talk further about what maybe people can do to help mitigate things. Like just like when you have rolling blackouts, right? Don't use so much power. Kind of take some of the strain off the grid yourself. That's something that we can do if the solar storm gets that bad. But I don't think it will. Okay, I just don't think this one's powerful enough. All right, let's see what other questions we've got. This is Bart. Hi, Tamitha. I noticed a steady rise in the noise on 10, 15, and 20 meters since 7:30 a.m. today. Yes, that's radiation storm related. So, Bart, that's absolutely the case. Especially if you're looking at high latitudes, if you're trying to do, or if you're trying to go over the poles. Oh, forget it. You probably can't talk to anybody doing DX over the poles right now, because the radiation storm is getting pretty bad. As a matter of fact, I'll show it to you. Ding dong, where are you? Where are you? D region. Yeah, you can see this. So I had a question today earlier on Twitter saying, well, I've never seen a solar flare look like this. Well, that's because solar flares don't look like this. Solar flares look like this, right? It's just what's going on the day side. So you're seeing that circle is really the day side of the Earth, and it gets lit up like that. There's that X flare. And it gets lit up like that because that's what the part of the Earth that actually sees the sun. Everything else is at night, right? But now, what's going on in the poles? Well, that's the radiation storm beginning to hit, because you have open field lines, and the particles actually end up penetrating the Earth's magnetic shield up at the north and down at the south. So that's what you're seeing. Okay, you're seeing the radiation storm beginning to take hold, and how strong it ends up getting, we'll see. The lower energy particles will end up probably continuing to rise. The higher energy particles will probably continue to fall. And that's actually overall a good thing, because it makes people safer who are airline passengers. We want that. It also makes spacecraft electronics safer from this stuff. So that's what you're seeing with the radiation storm, but it does impact, obviously, if this is DRAP, this is the D layer of the ionosphere, it is affecting radio propagation to some degree. And some of this stuff does leak. It leaks down. It also heats when the radiation storm hits. It also helps heat the atmosphere and all that kind of stuff. So it does leak past the boundaries that you see here. Okay, but that is likely what you're seeing, and it will continue to be kind of ratty and noisy for a while. Okay, hopefully that answers the question, Bart. Matthew, there are many things that could be a click away. Yeah, we can talk. We definitely need to talk about that offline. I owe you a video call. I know, and we've got to do that here soon. Peter Vick, and thank you, Matthew. I appreciate it. Peter Vick, Tamitha, is it possible in your presentations to mention the Southern Hemisphere space weather sometimes? Oh, particular regions in Australia. Yes, Peter, I just did. Hopefully you heard that. Yes, so again, aurora expected possibly as far north as Victoria in Australia. I don't think it's going to make Perth, but it could. If we get to a G3 level solar storm, then yes. So if we make it a KP of 7, then you could see aurora as far north as Perth. But definitely Tasmania and New Zealand, definitely. And then probably Victoria as well, down really the southern tip of Australia. And as far as radio propagation goes, in Australia, it's going to be about the same as it is at mid latitudes in the United States for most of that area, because you guys are pretty much mid latitudes. I don't think it's. I think you're going to also get the same thing, same issues with the radiation storm. That's going to be impacting you, and so radio comms is going to be just noisy. And then, of course, with solar flares, it's exactly the same, right? It's just the day side or the night side. They don't care what latitude. Sun doesn't care what latitude you live at, from the perspective of a solar flare and radio burst. So, okay, so hopefully that answers that question. Let's see her. Oh, that's sweet, Joseph. It says talk up what Dr. Scove does here with your friends. Let's see her top 500 patrons. Oh, that's so kind. You're really kind. Okay, so I'll refresh it one more time to see if any other patrons have put posts in the actual Patreon feed. And if not, then I will jump to YouTube and look at you guys. Oh, good, Lex. Okay, good. I'm glad you like the answer. Okay. Nothing bad will happen. No, I don't think so. The power grids should be fine. Okay, yeah, please don't be too scared. This is really not, I mean, this is a fun storm, but it's not a solar storm, but it's not, it's not a planet eater. It's not a kill shot. It's not, I mean, an X1 flare, they happen quite a bit during active times of the solar cycle. I don't think we've ever had a solar cycle where we didn't get something like that, at least not in our lifetimes, right? And it's I mean, we've ridden them out so many times. It's really more fun and more like minor inconveniences for people. If we get something like an X23 flare, something that's 23 times or 50 times bigger than this, well, not 50, but even 10 times bigger than this, I'll be a little bit more concerned. But I'd have to see something like an X5 or an X10 to even say, okay, this is scary. So although I'm taking this one seriously, it's not like I'm cavalier about it. I do think that the chances of it making grid operators wake up and run through the motions, I think it will. But I don't think it's going to be anything that's insurmountable. A lot of these grids are getting much more resilient than they used to be. But if it gets that bad, then I will be coming on and saying, hey, let's practice smart power usage and maybe kind of dial back usage during the daytime and see if we can, just for a day or two, right? And then get them through the worst of it. And hopefully, eventually, terrestrial meteorologists will start saying that type of thing. So then it becomes national things and then a multinational thing, so that anytime people are dealing with solar storms hitting, and it's mainly on the night side, that they become really really stressed out. But just for those couple days, I think we could handle doing that type of thing, even if we saw a KP9, a superstorm for a few days. Because remember, these things hit and then they go away. So it's not like a whole, it isn't like months and months and months of this. It's just for a short duration. So anyway, so hopefully that puts that into perspective for you. Okay, now I'm going to focus on the YouTube chat. How you guys doing? Hopefully, please tell me nobody is concerned that this is a, planet eater or something. Let's see. Yeah, you guys don't have to protect small electronics from an EMP. This is not a weapons grade EMP from this perspective. It's a global. So if your microelectronics were actually the size of a small country or the size of a big lake or a size of, something hundreds of miles across, then you could worry about it. But the fact that you got these small things, I wouldn't. The only thing that I would worry about right now is if I were a passenger on an airline flight with, let's say, an intercardiac device, right? If you have a pacemaker, or if you have electronics that you take with you that are implanted in your body, or that you have to have working perfectly, and now you want to get on an airline flight, I would strongly consider talking to your medical professional about the impact of soft resets. Because electronic devices when we have a hard radiation storm like we have right now, electronic devices have failures. They have soft resets typically, where they'll actually start over. As long as those types of resets aren't a problem for your device, then fly away. If you don't mind getting a little extra dose of radiation yourself. But if those are critical, like pacemakers, you might want to consider waiting just a few days and then get on the flight, because it's the risk is non-zero. It may not be, it's non-trivial. It may not be that big a deal, but I'm just, you have to make your own. I'm not going to diagnose or anything like that, but I just want you to take that into consideration and maybe have a talk with people. Get more informed, inform yourself, and then make your best decision based on the information you have. Okay, these radiation storms don't last that long, just a couple days. So if you're concerned at all about it and you have the opportunity not to fly, just factor that into your trade space. Okay. Your intercardiac device is beating. Cute. Tinfoil ball cap. Well, actually, you don't want to be wearing tinfoil. You really don't necessarily want to be wearing that, especially if it's thick. I guess tinfoil is not that thick, but nonetheless, because metal actually could be a source of radiation for you, because you get particles that come through it and then they actually create bremsstrahlung. So not necessarily the solution, sadly. Radiation is complicated. It's a complicated thing, and it's not intuitive. Okay, so what other questions do we have here? Will the same thing happen in 2003? Oh goodness, no. This is weaker. Yes, much weaker. Yes, I've noticed people are making the connections to the Halloween events. Yes, this is different. So don't worry about it. It's nothing like the events that occurred in Halloween. However, remember how those clustered? Well, we may have a cluster of events here as well. So just be aware of that just because we have this one coming, don't take your eyes off the sun, guys. The sun has a tendency to give you, when there's a bad actor on the sun, it tends to fire and fire and fire and fire and fire until it rotates out of view. So just be aware that we could be having more events coming, okay? And it's just all part of the process. Yeah, tinfoil will turn you into a capacitor. Very good, Matthew. That's funny. I should buy 6 gallons of milk just in case. Right. Is that the radiation dose? Homeopathic remedy. I don't know. I'd love to know what medical professionals recommend when it comes to dealing with living in high dose environments. Okay. Yes, Tracy, I'm so sorry. Physically, I feel like I got hit by a bus. If you happen to be talking about general malaise, yes, some people do. Some people get energized. Some people have general malaise. Know that if you're a sensitive person, physiologically sensitive, yeah, this could be a tough week for you. And just take comfort in knowing that it will pass. It is transitory, and things will get better. Okay, and you're not alone. There's a lot of people who deal with that problem. You're so welcome. One being everybody. What is my phone doing? Oh my goodness! Did you guys hear all that? Boy, that was funny. I just got a ton of something. I don't know what I got. I had one of my students just tell me something horrific, which I'm not going to repeat here, but oh my Lord. Okay. Yeah, solar protons. Yeah, I just got another oh, wait, is that now? No, that was earlier. Okay. Just checking. Yeah, we're getting more notifications on my phone about the space weather. Is kill shot a thing? Oh goodness, I hope not, Yardley. It's been a thing. I keep having people. How many people, out of curiosity, I'll get to ask you guys a question. How many people have been seeing other YouTubers talking about kill shots or doing fear mongering and scaremongering about this event already? Has there been a lot? Because this kind of thing just drives me crazy. So if you've seen it and they're doing it, tell me what they're saying so we can address some of that, because I do not want people to feel this way. A drop of iodine, right? That's actually some people actually do that. I don't know how. I definitely don't know how to. I don't know how to deal with iodine and stuff like that. I am not a medical professional, so I am not. Please talk with your medical professional when it comes to this type of thing. Don't just self-medicate if you are not familiar with it. I am not, so I will not say anything about it. Kill shot is a thing. They will scaremonger. Yeah, that's what I'm. Yes, racing pigeons they're not affected yet. Likely not yet. I don't know if the radiation storm is really going to affect the racing pigeons, but when the solar storms hit, they do. The racing pigeons absolutely get affected. So please, no pigeon races on Halloween. And that sounds completely ridiculous and completely silly, but I am totally 100% being truthful. You could risk losing your pigeons, um, especially when that storm hits Earth and it really rattles the Earth's magnetic shield. The poor pigeons aren't going to know what's gonna hit them. So definitely no racing pigeons. I know it sounds kind of funny, but I actually have several people who have contacted me and told me about this, and that's why they actually follow me, was because they race pigeons for for a hobby, and and they raise them, and so they don't want to lose their their prize pigeons, right? They breed them. They there's all sorts of stuff. I guess this is getting annoying, isn't it? So yeah, do not lose your pigeons. Should I just play the? I'll play the solar storm, the sun again. Like the other one wasn't annoying enough. We'll just play that flare just hitting over and over again. The kill shot is a double hit flare, and then while shields are down, a second Earth directed flare. Well, oh, is that what it is? Okay. Well, remember too, it's a the solar flare doesn't really give you anything. It'll give you, you can have a radiation storm that's being launched with it, and you can have a CME, a coronal mass ejection, or AKA a solar storm being launched with it. But the solar flare itself doesn't do anything but basically affect radio communications, and definitely at HF frequencies because of the X-ray and the EUV flux, but also if there's a radio burst associated with it, then it can affect it clear up to G, the L band and the K band. So you can actually have satellite transmissions being blocked, right? Being drowned out by the sun's screaming, because I call it the sun screaming. And that's really all a flare does, right? But it's the coronal mass ejection that comes a few days later that hits you and causes aurora and causes all these other types of disruptions. So often you'll get a solar flare and a coronal mass ejection, one after the other, and that's common. But getting another solar flare after getting hit by a solar storm, a big CME, that's not going to hurt Earth. That's not a problem. Those are just more irritating for satellites and radio comms. Okay. How about a 0-bit flip during? Yeah, is exactly right. Yeah, you do get, that's one. The memory upsets, bus retries, telemetry issues during solar energetic particle events, meaning radiation storms. That's the type of stuff you get. They're called single event effects. It's almost as if you flew right through the South Atlantic anomaly all the time, right, when these radiation storms are happening. And what's driving these radiation storms is actually the shock wave in front of the big solar storm that's coming. This is why those radiation storms continue to stay strong all the way until that big solar storm reaches Earth, and then it begins to die down, because now that shock wave is past you. So the thing that's generating all that noise and all that nastiness is now beyond you, and it's firing out that solar radiation storm further out into the heliosphere, beyond planets past Earth. So that's why we have to wait for that solar storm to arrive before that radiation storm will really die down. Okay. How much speed does a CME arrive on its way to Earth? Man, it depends upon if there's fast solar wind behind it or not. I haven't checked, and we're not really good at predicting that, sadly. Let me check the model again real fast. Does anyone know if NOAA has put out a prediction yet for this structure? They have a better, NOAA's version. This is NASA's version of NLO. NOAA has a version of NLO that is really designed for solar wind. So the pinwheel arms, NOAA does a better job at doing the pinwheel arms than does NASA. As far as I know, maybe NASA's updated their NLO, but I'm not sure if they have yet. But NOAA's definitely designed better for that. And I'm looking at it, and well, we've got we do have a little bit of a right here, this pinwheel arm, if I draw it, that is a stream interaction region. So it's possible. That's a good question. Let me see. I would rather look at NOAA's than NASA's to get that. And when you see the no, I think in this case, because of where the stream interaction region is, I think it's going to slow the structure down. I think it's still going to be faster than fast enough to drive that shock. But if anything, I think that seeing that stream interaction region ahead of it and kind of in the middle of it is going to, so you can actually see it just ahead. If this model is anywhere close to reality, this structure is going to be slowed down by hitting the stream interaction region, and so it will lose some of its speed, maybe more than it normally would if everything were cleared out. So maybe that, sadly, that could slow the structure down, but it also could compress it more and make it stronger. So it's really impossible to tell. Just because you have so many different things that are coupled, right? And so you have to take many more than just one variable. It's not just the speed of the structure, as to, that dictates how strong a storm it is. So don't know, guys. I don't know. But I do think this one it'll slow. It's definitely going to lose some speed on its way here. There's no doubt. Oh, did somebody just check? NOAA has not put on their prediction yet? Okay, thanks, Matthew. Appreciate it. Can you imagine talking to the preacher in a solar hit? I'm missing that. That went up. Sorry, I missed that. Questions, guys. NOAA's issued a G3 storm warning. Right. Should be G3 at high latitudes, G2 for lower latitudes. At least that's what they're for lower latitudes, not lower latitudes, mid latitudes, but it's definitely a G3 level solar storm is what they're expecting at high latitudes. So get ready for that. But one of their predictions, their 3-day prediction right now is kind of, like I said, it's a little bit conflicted because they're expecting the G3, which is a KP of 7, but then they also have major storm risk or potential, and the percentages are 1%, and it's like, what are you doing, guys? It's a little bit odd. So do we know how far the aurora will reach when the solar storm hits? The solar flare already hit. Solar flare is here and gone. Solar flare hit back on at 1500 hours today. The solar storm will hit on the 31st ish, maybe a little bit prior, maybe a little bit after. And how far will aurora go down? Well, I did mention that earlier. It'll be probably, if it ends up being a G2 in the in the UK, if it hits in the UK, it could be seen as far south as the Netherlands, possibly Germany, and maybe even the northern part of France. Maybe, definitely that far south, so you could get down to easily Ireland, definitely England, different parts of England. Obviously, Iceland, yes, Norway, all those places. When we get across the pond and come to the United States and Canada, obviously in Canada, all the way down, potentially down into places like New York, Iowa, maybe even a little bit further south, if it's sustained, like places like Colorado, moving off to the West Coast, it will be Oregon, maybe even the northern part of California. We could definitely see aurora those in that far south. And if you happen to be in Australia, you could see aurora easily in New Zealand and Tasmania, possibly up to Victoria if it's a G2. If it's a G3, depending upon how long it lasts, it could actually get up to Perth, okay, that high, that far north. So just be aware of that. And like I said before, if you're at super high latitudes, you might have to look south. If you're in the northern hemisphere, you might have to look south for the aurora. If you're in the southern hemisphere, you might have to look north for the aurora. Because the auroral oval will have passed over you and you will be completely inside it. So the aurora will be on the opposite side of the sky than you expected. Because this will be a bigger storm. If we get to a G2 or G3 level, okay? So just be aware of that. Other people who are at mid-latitudes, take a camera with you. The camera's CCD, sees a lot more than your eyes do. So point it toward either the north horizon if you're in the northern hemisphere, southern horizon if you're in the southern hemisphere, and take long exposures, okay? Because it might pick up glow that you don't see with your naked eyes. And if you can, climb a mountain. Get off the ground. The further off the ground, you can see further over the horizon. So aurora that you might not see if you're down at low elevation suddenly becomes visible if you're at higher elevations. Okay. Volcanoes and earthquakes have been tied to solar flares and CMEs. Yeah, I know, and I've talked about that so many times in my mini courses. I will not address it here because this kind of stuff is impossible to predict. I can only do the space weather at this point. But I do address it quite often in the mini courses, so please check them out. I hope you get to see it in Ohio. Well, just this last G2 level storm, it was seen in Cleveland, right? So it was even seen in Nebraska. I should have mentioned Nebraska. We have a chance to see it in Nebraska again. So Sarah Husial, if you're out there, you get another chance. Hopefully you're not working it. You're welcome, Susie. I'm so glad to see you here. I'm glad. Hopefully this is informative to you guys and you're enjoying this. And sadly, I have to teach a class for Millersville here in about 10 minutes, so I will have to be leaving you all here shortly. Hip stuff. Cool. There is no evidence that solar activity causes earthquakes or volcanoes. Yeah, Matthew, I know it's a secondary or tertiary effect if that we can't quantify it. That's the problem. Geophysicists have to subtract out the primary driver first before we can really begin to quantitatively assess whether or not space weather has an effect, a measurable effect on earthquakes and volcanoes. It has an effect on lightning. We know that. I mean, there definitely get intensifications of lightning and hurricanes. And we are seeing sprites and jets, and there's some type of coupling between the neutral atmosphere and the charged atmosphere through sprites and jets and gravity waves. We are seeing that type of thing, but it's a field that's very understudied, at least in mainstream science, because it's just so hard to do. There's a lot of speculative science out there, but you can't quantify it because we just, mainstream science is glued to much more rigid rules of engagement, so to speak, than is fringe science. So, right now it's still the realm of fringe science, how earthquakes and space weather are connected. And mainstream science has to wait for the geophysicists to catch up. And like I said, I talk about that an immense amount in pretty much every mini course, because it's always during my Q&A especially, because I get so many questions on it. Oh, thank you. Best teacher ever. You're so kind. You're welcome. You're welcome, Deepquake. I'm glad you I don't remember what it was I answered, but I'm glad. Where do I download what vid? This vid? Go to the NASA Donkey database, DONKI, and take a look. That's where you get those. That's where you get that. I annotate mine, so you won't get with all the pretty things all over it. So I annotate this. What you get is just the plain GIF animation. So and I've converted it to a movie so I could actually freeze it at the right time. Okay. So hopefully that answers that question. Can't prove a negative. Yeah, really tough too. Let's see. Aurora predicted to be best Saturday or Sunday night. Let's see. I'll put my 5-day up again. Oops, I probably should stop this. Just stop. There. So I'll put this back up so you guys can see this. So this is the best guess I have right now, and it was done slightly hurriedly. So we could be seeing some storming depending upon if you're at high latitudes or at mid latitudes. You could be seeing some storming easily in through Monday of next week, possibly into Tuesday, or if you're at mid latitudes, likely we might see it die down by the Monday. But again, there's a chance that more solar storms will be launched, right? We have a chance for more flaring and more solar storms. So don't take your eyes off the sun simply because we do have a storm coming, okay? Because we could get more. So this obviously this forecast would change quite quickly at that point. Tamitha, you look worried. Nah. You know what I'm worried about? I'm worried that I'm going to give a bad forecast. That's what I'm worried about. I'm a typical weather forecaster going, oh, I hope this is right, because I want to give people good information. I'm not worried that there's going to be something, that's going to affect us in any horrible way. What I would love would be that it affects the ISS in the sense that it makes surgeons wake up and say, hey, oh, the sun is waking up. We got to take space weather more seriously. And it makes because we've been sleeping for so long because it's been solar minimum. And it makes SpaceX wake up, and it makes launch, people in launch wake up, and it makes satellite operators wake up and go, oh, okay, we're getting serious again. We need that kind of thing. And then obviously I would love it if it caused issues for GPS and makes drone pilots wake up and say, oh, I can't trust my GPS right now. Especially, the radiation storm right now, if you're at high latitudes, anybody who's trying to do geological surveys or any type of survey, right, using drones at high latitudes right now, you're in a world of hurt. And you're going to be in a world of hurt for several days because you're like, why can't I get a lock? Why can't I get a GPS lock? Why can't my machine work? Why do I have to go VFR flight rules? Why is this happening? Because we have a radiation storm going on right now and your GPS isn't going to work. The reception, you can't receive a robust GPS signal for very long when you have a radiation storm. And then when the G3, if it is a G3, G2, G3 storm hits, that's going to just exacerbate the situation. So I hope any drone pilot who happens to be paying attention takes heed, right? Don't fly, if you can, don't fly at high latitudes. Definitely don't fly at night, and do not fly under the aurora. You know, unless you're an aurora photographer with a drone and you know what you're doing, then take it under VFR flight rules, okay? Because your drone will do weird things, okay? X-class in the way of very high intensity, yeah, exactly. Okay, so I have to go back to VORs. Who said that? Who said that? Yeah, are you a pilot? I don't know. Just be aware. You know, just be aware. Hopefully, hopefully ADS-B is not going to have a problem if you're using ADS-B out. If you're flying over high latitudes or in the poles, you might though, because radiation storms are they're not fun for really any frequency. Most the high frequency stuff can get through that transponders at like 1070. You're sitting in essentially in the L band. It could still have problems. So just be aware if you're in that auroral oval, and you might have issues with your nav. So just be aware and just, you know, be vigilant. That's all I ask. If you're a commercial pilot, though, if you're flying the big jets, probably fine because you have really good inertial nav systems. But if you're in one of the smaller planes and things, you know, private stuff that doesn't have those $1 million boxes sitting in there as inertial nav systems, you know, just be more aware, right? If you're flying in Alaska, for example, right, on a little Cessna, just, yeah, you could have issues. Okay. So any other questions, guys? Because I'm going to have to get off here. Old enough to remember using Loran. Very good. Oh, then you'll love Mike Richardson. Yeah, one of our VIPs, one of the moderators in here. You guys could have a really good conversation. At least Loran is coming back, right? We've got we had that sign to come back on because that radar system was really valued, and they realize how we need these redundant systems that are different from one another. So we definitely need VORs and DMEs. We definitely need Loran if we can keep it, as well as satellite-based transponders. And I know that probably sounds like Swahili to most people who are like, what are we talking about? Well, we're talking about navigation, different styles of navigation equipment and methodologies for pilots and the like, and for maritime and all that kind of stuff. But some of these are space weather susceptible, so we need different technologies to be able to mitigate through a solar storm really well. Okay, guys. Yes, get to my class. Thank you. I do need to go because it's almost 4:30. I'm glad you guys enjoyed this, and hopefully now, yeah, Mike says bring back Loran. Hopefully now you know, relax, relax, relax. If anybody's fear-mongering over the next couple days about this solar storm and you see a lot of that stuff, just laugh and enjoy yourself. Look at it as entertainment, okay? We will have a good storm likely. There'll be lots of aurora, but the planet is not going to crack in half, and the sun is not going to eat us alive. We're okay. We really are. Okay, guys, and I'll talk to you soon.